Are they? Sure. Lots of exponents. So, for lots of exponents, let's think. What do we have here? For you to have an exponent, you have a base, right? So if you have a to the power of n, this is your base, and this is your exponents. The interesting thing is that we have dealt with exponents even when we were factorizing with those x squared or x to the power of 3, those were exponents, right? So we do know how to deal with exponents, right? And the thing is, for this this it has to be a real number, right? Implying that it could be any decimal, it could be either a decimal or just a whole number, but it has to be a real number. And then this one, it has to be a natural number. Remember, natural numbers from 1 to positive infinities, right? Cool. Or positive integers. And now the question is, what does a to the power of n mean? Like, what does it mean exactly, right? The definition is, say we are multiplying a by itself n times. You see, so um that will be like a times a times a times da 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 um times a n, right? That's when this is the nth a, right? So you're multiplying a by itself 10 times. So now we'll make an example with a couple of numbers. When we have 2 squared, we are saying multiply 2 by itself 2 times, right? Which is 4. And when we have 2 to the power of 3, we are saying multiply 2 by itself 3 times. 2 times 2 times 2, which is 8. 2 to the power of 4, we are saying multiply 2 by itself 4 times. 2 times 2 times 2 times 2, which is what? 16. Right. So, yes, beautifully, yes. So, that is what an exponent actually is. That's what an exponent is, or that's what it means. So like I said, in this video we're just going to talk about laws of exponents, so let's dive in. All right, I will use this box for making examples or illustrations. So yeah, we have this one that says you multiply bases. When you multiply the same basis, you're gonna add their exponents, right? So you have a being the same as a, right? And we're multiplying these two bases a, therefore we add their exponents, right? So now we have 3 multiplied by 9 is the same as 3 multiplied by 3 to the power of 2, which is, this is 1, 3 to the power of 1 plus 2, which is 3 to the power of 3, which is 27. Right, so it is that whole idea, you see. Cool stuff. Then we have this one when we so this one, it says when we have the same basis and we divide, we're going to subtract their exponents, right? So say 3 9 divided by 3, it's the same as 3 to the power of 2 over 3. Then we have the same basis and we are dividing, therefore we subtract their exponents. You have 3 to the power of 2 minus 1, which is 3 to the power of 1, which is 3, right? And of course we know this is 3. We have other laws as well. You have when you are okay, so basically this one is you have one here, you have one here. This law, you see this law, both of these ones, they are the same as this law, right? In a sense, I want to say when we are raising power to power, we multiply the exponents, right? So let's focus on this law just a little bit. So we are raising power to power here, therefore we will multiply the exponents, right? So it's like, for example, I have 4 squared, which is the same as 2 squared, right? Now I'm raising power to power, and therefore I have 2 to the power of 4, which I know the answer is going to be 16. All right, so raising power to power, we multiply the exponents. Like, so here for this one it could be a bit tricky because someone could think that I added them. So let me use a different example. A different example will be, let me see, so we are raising power to power, right? Let me see, I'm trying to think. 3, okay, let me use 3. So I have say I have cool, beautiful, I have 9 squared. No, 9 squared is not very. Let me see, 9 squared, because I have 3 squared, then okay, I bet. I can't really think of a number just from the state of mind. But it's that idea, you multiply. So if I have just 5 to the power of 3 and then to the power of 2, I'm raising power to power, therefore I multiply the exponents. Therefore I have 3 times 2, which is 5 to the power of 6. That's the idea. So now when we come back here, you realize that we have power 1, so therefore n multiplied by 1 is n multiplied by 1 is n. So both of these products, they will be to the power of n. And the same is true also here as well. We're dividing, but we still have power 1, right? So raising power to power, multiply the exponents, 1 times n, 1 times n, right? Fair. And then the last one that I have is that a negative fraction, right? Oh, no. When you have a negative exponent, it gives you a fraction, right? So, for example, negative this, it's going to give me 1 over a, right? But now, if this has a number like here, negative n, it's going to be 1 over a to power of n, right? Like negative, no. 3 to the power of negative 2, it's gonna be the same as 1 over 3 squared, which is gonna be 1 over 9. Right, so these are laws of exponents, and when we are applying them, remember both a and b, they have to be 0, and both m and m, they have to be real numbers, right? So cool stuff. Let's get started. We're gonna solve a couple of problems now. So without using a calculator, of course, very important here, you already see that you have the same basis and you are multiplying. So what are we going to do? Add the exponents. All right, and therefore your answer is going to be 11 to the power of 11x. Funny. Here we're raising power to power, we multiply the exponents. You have 5 to the power of 3 and to the power of 3, which is 125 to the power of yes, and to the power of 3, right? Then here, multiplying the same basis, we add the exponents. You have x to the power of 2 plus 3x, 3t plus 1, right? Then you have x to the power of 3t plus 3, right? Just basically using laws of exponents here. Same basis, you are dividing, you subtract the exponents. Therefore, you have a to the power of 2 minus into minus 1, which is a to the power of 2 plus 1, which is a to the power of 3. All right, cool stuff. Also, another way you could do it like this and say you have a squared divided by 1 over a, and then you have a squared multiplied by a over 1, and then you have a squared plus 1, you have a to the power of 3, right? Yeah, same basis, we multiply, add the exponents. You have 3 to the power of 1 plus 2a plus 2, the answer 3 to the power of 2a plus 3. Beautiful. Same basis, divide, we subtract the exponents. Therefore, you have 2 to the power of x minus 4, it's x plus 4, then minus x plus 3. You have 2 to the power of x plus 4 minus x minus 3. Therefore the x, they cancel out. 2 minus 3, that is 2, so the answer is just 2. All right. Cool. This one, okay, this one, okay, let me do it this way. So you have 13c plus, here you see that we did add the exponents, so I could say you have 13c multiplied by 13 to the power of 2. All right, and then you have 3 multiplied by 13c minus 13c. So you see that in all numerator or denominator you have a common factor of 13c, so I'm gonna take it out, 13c. Then I have, come on bro, 1 plus 13 squared, right? 13c into 3 minus 1, right? So that's a 13c. So here you could maybe then say, since we are using laws of exponents, you could say this is 13 to the power of c minus c. Oh, there is one other important one that I left. There is a very important rule that I left. So this rule, it says anything to the power of 0 is 1. So yeah, a to the power of 0 is 1, right? Come here. So here you have you're gonna have 13 squared. 13 squared, let me see, it's going to be okay, 13 to 13, we're gonna have 1, and we have 3, we're gonna have 6, and then we have 9. Oh, beautiful, beautiful, beautiful. So you're gonna have 190, 169 divided by 2, right? And then it's gonna be 13 to the power of 0 times 169 times over 2, which is just 169 over 2. Right. Let me see if yeah, cool. But yeah, we're done. Yeah. just for vibes, ne? There's this method, like when you multiply numbers. So like say you have 13 squared, which is 13 times 13. So basically you take 1 and 1, you multiply, then you cross multiply. 1 and 3, it's 3, 1 and 3 is 3, so you add the 2, 6, and then this one squared, 9. Right. So it's even advised that you start from then you start from with the last numbers, to say this is 9, and then you go here 6, and then 1, right? So I'll just do it again. Maybe let me say 24 squared. 24 times 24. Okay, cool. So you start here, this is 16, so you have 6, then 1, and then you go again 8 plus 8, 16, plus 1, 17, and then we go again, then 2 times 2, 4, then 5. Let's just test it. I just want to see. Cool. So 24 squared. Beautiful. Cool. So let's do this one. Number 8, we have something very interesting. I'm seeing difference of 2 squares, né? So here's how I see. So here you have 4 x. Okay, you have 4 squared here, né? 4 2x, né? But for convenience, I'm gonna write it as x squared. It's still the same thing, because we raise power to power, multiply the exponents, same thing, right? So then we have minus 12. I'm gonna do the same here, squared, still the same thing, right? Then we have here, perhaps I can just leave it like this, 4x minus 12. I factorized there. I'm gonna have 4 to the power of x minus 12b, and I'm gonna have 4 to the power of x plus 12b, right? Yeah, but I think here we didn't use any laws of exponents. I don't know, maybe the power to power 1, 4 to the x minus 12b, right? Because then here this divides this 1 1, and then you're left with 4x plus 12b, right? If you want to be very mysterious, né? If you want to be very mysterious, you could say this. You could say this. B. You could say you have okay, let me start 4x plus 4 times 3b, and then 4x plus 4 to the power of b, 4 to the power of b plus no, multiply by 3 to the power of b. If you want to be mysterious, yeah, it's scary. Okay, let's go this one. So this one, okay, there's this thing, especially you're gonna meet a lot of it when you're doing exponents. You're gonna meet a lot of it. So basically, when you have a number with exponents, you try to divide the number. Like for you to break down the number, you're gonna try. So you want to break it down into its prime number. So you want to write the number as a product of prime numbers. So when you divide or try to break it down, you make sure that you start with the lowest prime number as possible, and then you go high. Yeah? For example, 6. For 6, yeah, the lowest prime number that can divide 6 is 2. So that means I can say I have 2 multiplied by 3 to the power of all to the power of 4 times. And then for 12, we have what? We have 2, right? Because 12, I have 4 times 3, and then this 4 goes into 2 times 2 times 3, right? So here I have 2 times 2 times 3 to the power of 3, right? Let's do this, and then we have 4 to the power of, maybe let me say 2 squared to the power of 5. That's for the numerators. As for the denominators, 30, I have 2, right? Because 15 times 2, right? And then I break 15 to say 3 times 5, right? So it's gonna be 2 times 3 times 5. This gives me 30, so it will be to the power of 3, right? Ouch. Damn, I'm just having just a slight headache. Then we just have multiply by 3 times 6. Damn. Okay, cool. Now we're gonna raise power to power. We're gonna multiply the exponents basically. So we have 2, that is 2 to the power of 4, that is 3 to the power of 4, that is, you have 2 squared here, 2, or let me just say 2 to the power of 3 times 2 to the power of 3 times 3 to the power of 3 times 2 to the power of 10. Then 2 to the power of 3 times 3 to the power of 3 times 5 to the power of 3 times 3 to the power of 6. Oh, apparently I'm running out of space. So now it's gonna be 2 to the power of 4 plus 3 plus 3 plus 10. Multiply by 3 to the power of 4 plus 4 plus 3, right? Divided by 2 to the power of 3 times 3 to the power of 3 plus 6 times 5 to the power of 3. Right, let me remove this. Okay, What the hell just happened? Cool. So from here on, then I have 2 to the power of, this is 10, 20, that is 20, that is 7, that is 2 to the 3 times 3 to 9 times 5 to 3. Right, then I have 20 minus 3, then I have 3 to the power of 7 minus 9, then I have, okay, look what I'm gonna do now. I don't have a base 5, but I know 1 is anything to the power of 0 is 1. So I can say here I have 5 to the power of 0, right? Then I will have 5 to the power of 0 minus 3, right? Which I'm still running out of space. Which the answer after all of that is going to be 20 minus 2, that will be 17, that will be 3 to the power of 9, 7, 8, 9, minus 2 to the power of 5 minus 3, which I have 2 to the power of 17 divided by 3 squared, 5 to the power of 3. Then I'm done. Let's see. Okay, so that's the end. I'll see you guys in the next video.